Now in today's class we will go through covalent bonding, right? Before this, till our previous lecture we are done with electrovalent bonding, right? Now we'll go through another way, right, using which atoms can achieve stability, right? So covalent bonding, we call it as Lewis and Langmuir concept. Why we call it as Lewis and Langmuir concept? Because the theory was first given by Lewis and later it was improved by Langmuir. So we call it as Lewis-Langmuir concept, right? Now we understood in the beginning that there are two types of bonding: electrovalent bonding, right, in which there is transfer of electrons from metal to a non-metal. And the other way is covalent bonding, right? Covalent bonding. In covalent bonding, we have covalent bond will result due to sharing of electrons, right? There is no transfer of electrons, there is sharing of electrons. We'll understand the reason why sharing of electrons and why not transfer. This is due to sharing of electrons between similar or dissimilar non-metals, right? So in case of electrovalent bond, we have one of the atom was non-metal and the other was a metal, right? And transfer of electron was from metal to non-metal, right? And if you remember, metal used to have 1, 2, 3 electrons, non-metal used to have 5, 6, 7 electrons, right, in the valence shell. Now covalent bonding is between non-metals only, right? And electron transfer will not take place, right? Only electron sharing will take place, right? So here only electron sharing will take place. Example is oxygen, nitrogen, hydrogen. These are simple molecules that we will understand first. Taking the example of these molecules, we will understand all the concept of covalent bonding and Lewis and Langmuir concept, right? Now, why sharing? First thing that we will go through is why sharing, why not transfer, right? Why sharing take place and not transfer, right, between non-metals, because this bond is between non-metals, right? And it is, and we'll also see how come, because we know that bond is nothing but a force, right? So how sharing of electron will result into force of attraction between two metals, right? So here we can also add one more point. This is say first point. The second point is sharing of electrons will result into force of attraction between non-metal atoms, right? And why? Okay, that's fine. Sharing of electrons will result into force of attraction between non-metal atoms, right? And how this force of attraction is generated, and it is this force of attraction that will hold, say, these two atoms in the molecule, right? We'll understand how this force of attraction will hold these two atoms A and B in the molecule AB, right? We should be clear about on these concepts. So why sharing take place, why not transfer? If you remember, in the beginning of this chapter, chemical bonding, we understood that metals have 1, 2, 3 electrons in their outermost orbit and non-metals have 5, 6, 7 electrons in their outermost orbit, right? And it is easy for metal to transfer 1, 2 or 3 electrons, because we need to give energy in order to remove electrons from the outermost orbit in order to transfer, right? Whereas, so energy required to transfer 1, 2 or 3 electrons would be less compared to energy required in case of non-metals which has 5, 6 or 7 electrons in their outermost orbit, right? So the energy that is required to transfer 5, 6 or 7 electrons from the outermost orbit, right, is high, right? Energy, this energy is high, and this high amount of energy, right, to transfer electrons is normally not available in normal chemical reactions, right? So instead of, now since covalent bonding is between non-metals only, and we say that non-metals have 5, 6 or 7 electrons in their outermost orbit which cannot be transferred, right? Instead they would be sharing of electrons, right, if chemical bonding is between non-metals, right? So due to high amount of energy requirement, right, instead of transfer of electrons, sharing of electron will take place, right? So first is due to high energy for transfer of electrons, sharing will take place. Sharing will take place instead of transfer, right? And what do we call this energy? The energy required to remove electrons from the outermost orbit. What do we call it? We call this energy as, ionization energy or ionization potential, right? So that means non-metals have high ionization energy, right, due to which sharing of electron will take place, not transfer of electrons. We know that if you want to transfer electron from a metal atom, right, you need to give energy equal to ionization energy, right? But here the value of ionization energy would be high, so transfer will not take place. Instead, non-metal atoms will prefer sharing of electrons, right, to achieve stability. That is to achieve 8 electrons in their outermost orbit. So once they will share electrons, they will form 2 or 8 electrons in their outermost orbit to achieve nearest noble gas configuration, right? So let's quickly take an example. Okay, one more thing. The elements, right, that have covalent bonding, right? We know these are non-metals, right? And these non-metals mainly belong to 5th, 6th or 7th A group of the periodic table, right? These belong to 5th A, 6th A or 7th A group of periodic table, right? This is important. And we know that atoms that are in 5th, 6th and 7th A group of the periodic table are your non-metals, and they have high value of ionization potential, because as you move towards right of the periodic table, the value of ionization potential will increase because of increasing nuclear charge. When nuclear charge will increase, it will have a tight hold on the valence electron, due to which you need to provide more energy to the valence electrons in order to remove them, right? So high value of ionization potential for these elements, right? That is why sharing will take place. So I'll just mention one more thing. I'll just write it over here. For these elements, ionization potential is high, right, due to increased nuclear charge on moving right, in periodic table. Right. Now let's quickly take an example. Let's take an example of hydrogen. We know that hydrogen has hydrogen molecule. We'll look at the formation of hydrogen molecule. Right. In hydrogen molecule, we have two hydrogen atoms, and these two hydrogen atoms are bonded. Right. These two hydrogen atoms are together in this molecule due to force of attraction. Right. This force of attraction is resulted due to sharing of electrons, right, which is a covalent bond. So let's see the formation of covalent bond, how covalent bond formation takes place between hydrogen atoms. Hydrogen is it has one electron, another has one electron. So we started in the beginning that every atom will try to achieve 2 electrons like helium or 8 electrons in its valence shell. Right, so hydrogen, in order to have 2 electrons in its valence shell, it will share one electron. This hydrogen atom needs one more electron to achieve doublet, that is 2 electrons. This hydrogen atom need one more electron to achieve doublet. So both these will share their electrons, right, and they will form hydrogen bond. Since this is now a shared pair, right? This is, both the hydrogen atoms have shared one electron each. We call this as shared pair of electrons. Shared pair. So this dash represents the shared pair of electron. This dash is your bond. Now we know it's a covalent bond, right? And this bond, one line represents one shared pair. Right. So here this one line will represent one shared pair. One shared pair means one line, like this. Right. Now let's take example of oxygen. Oxygen, if you remember, you put a double bond, right? So here you have single line, here you have double line. Single line, one shared pair. Double line, that means 2 shared pairs. Right, now we'll see how 2 shared pair took place here. Right, and the electronic configuration for oxygen is, its atomic number for oxygen is 8. Right, so its electronic configuration would be 1s2, 2s2, 2px2, 2py1, 2pz1. Right. So what we are doing, these are Lewis structures. We are drawing Lewis structures. Lewis structure is when you draw the symbol of the element or the atom and you put all the valence electrons around the symbol. Right, since we have 2 oxygen atoms in oxygen molecule. Right. Now if you look at this oxygen atom has 6 electrons. Right, if you look at the electronic configuration, it's 1s2, 2s2, 2px2, 2py1, 2pz1. Right, 1s2, 2s2, 2px2, 2py1, 2pz1. Right. Now this oxygen atom needs 2 electrons to complete its octet. That means to complete 8 electrons in its valence orbit. Similarly, this oxygen atom also needs 2 electrons to complete its octet, or to complete 8 electrons. So both these will share 2 electrons. This oxygen atom needs 2 electrons. So it will share from here, from this oxygen atom. This oxygen atom needs 2 electrons, so it will share with this. So both these will share oxygen atom. Both these will share 2 pair of electrons. Here it was 1 pair of electrons. 1 pair of electron means 1 bond, single bond. So here we have 2 electron pairs, that is why double bond. Right? So it's like this. right? Now one important thing that we need to understand here is these are shared pair of electrons, right? Like we said here, since these electron pairs are shared between two atoms so as to achieve stability, right, by attaining 8 electrons in the outermost orbit. So we call these as shared pair of electrons. And it is these shared pair of electrons that will result into chemical bond or covalent bond, right? This shared pair will result into covalent bond, right? Now this is shared pair, right? Since this has resulted into covalent bond, right? This has resulted into covalent bond, so we call it a bond pair of electron. We call it a bond pair of electrons, right? This is a bond pair that has resulted into chemical bonding, which is a covalent bond. Now these electron pairs have not taken part into bonding. Only shared pair have taken part into bonding. So these are known as non-bonding pair. This is your non-bonding pairs. Oxygen has 2 non-bonding pair of electrons, right? So this concept is important. Electron pairs that take part in bonding is your shared pair, or we call it a bond pair. Shared pair of electrons are bond pairs that will result into chemical bonding, whereas the other electron pair that will not take part in bonding is your non-bonding pair of electrons, right? So this is the concept of shared pair and your bond pair of electrons. Now we also call these as, since this is the shared pair, since the shared pair has resulted into bonding, so we call it as shared pair. We also call these as non-bonding pair, an unshared pair. Since this we have not shared this, right, in chemical bonding, so these are unshared pair of electrons. Unshared pair of electrons, right? And mostly in future lectures we will be calling this by the name of lone pair of electrons. This non-bonding or shared pair of electrons are also known as, these are also known as lone pair. Lone pair of electrons, right? So we have lone pair and shared pair of electrons, right? This is important. We have lone pair of electrons, right, which does not take part in bonding, and then we have bond pair. This is important, lone pair and bond pair. Bond pair of electrons, which bond pair are shared pair that results into covalent bonding. Right? So this is the kind of bonding that we have in covalent molecules. Right? We have shared pair, lone pairs. Right? Now let's look at the element that belongs to sixth group. It's oxygen. Right? This oxygen, it's nitrogen that belongs to sixth pairs. Nitrogen. Fifth, oxygen belongs to fifth. Let's write it as atom. Oxygen atom belong to sixth, nitrogen belong to fifth, sixth, and fluorine belongs to seventh. Right? So oxygen fifth, nitrogen sixth, fluorine 7th, and all these are non-metals that have high value of ionization potential, so these have to share electrons, right, to form bonding. Nitrogen, let's quickly draw for nitrogen. Its atomic number for nitrogen is, so now it's clear that this one line will represent one bond pair or one shared pair, right, single bond. So single bond, wherever you see, it means it has two electrons, right, which is a shared pair of electrons, right. So two shared pair, two lines means two shared pair of electrons, right. Now let's talk about nitrogen. Its atomic number is 7. Electronic configuration will be 1s2, 2s2, 2px1, 2py1, 2pz1, right. Now, okay, one more thing. In future, we would be looking this as interaction between orbitals. When these shared pair, right, the sharing that is taking place, it's due to interaction between these p orbitals. Since we have nitrogen, two atoms of nitrogen, so both atoms of nitrogen, right, in both atoms of nitrogen, these 2px, 2py, 2pz orbitals will interact, right, and they will form two electrons in their orbitals, because an orbital can have maximum of 2 electrons. Similarly here, oxygen has half filled 2p1 and 2pz and 2py orbital. So this 2py and 2pz orbitals in both oxygen atoms will overlap, right, will result into bonding, right. It's basically the chemical bonding is due to these orbitals, right, half filled orbitals. So there is one more thing, that the atoms that are taking part in covalent bonding should have singly occupied orbitals, right. They should have half filled orbitals, what we call, right. So I'll just take this point here, that atoms taking part in covalent bonding, this concept should be clear from the previous chapter, atomic structure, where we have learnt about filling of orbitals, electronic configuration, right. If you have any doubts, you can go back and look at those lectures. Atoms taking part in covalent bonding should have half filled orbitals, and it is due to these half filled orbitals that this bonding will take place. We'll see that in future, right. So let's quickly see nitrogen. Nitrogen, we know, has 7 electrons in its outermost orbit, right, like this. It has 7 electrons in its outermost orbit, right. 2, 2, 2, 1, 7 electrons. I'm sorry, it has nitrogen atom has 5 electrons in its outermost orbit. The electronic configuration is 2, 5. I'm sorry for that. It has 5 electrons in its outermost orbit. Right, 5 electrons in the outermost orbit. Similarly, other nitrogen atom also has 5 electrons in its outermost orbit. So both these nitrogen atoms, what they will do is, this nitrogen atom has 5 electrons on it, so it needs 3 more electrons. This nitrogen atom has 5 electrons, so it also needs 3 electrons, right. So these two nitrogen atoms, this nitrogen atom has 5 electrons, so it will share 3 electrons from this nitrogen atom. Similarly, this nitrogen atom will also share 3 electrons from this nitrogen atom. So both nitrogen atoms will share 3 electrons, right. So these 3 electrons that these two nitrogen atoms are sharing are shared pair. We have three shared pair of electrons, right? So let's redraw these. It would be like this. Let's draw it. Right? So these nitrogen atoms will share these three electrons, I'm sorry. Each of the nitrogen atoms will share 3 electrons, right? And these are 3 pairs of electrons. 3 pairs means 3 dash, that is triple bond. Here we have 2 dash double bond. Here we have 1 bond, 1 shared pair, 1 bond, single bond, right? 2 shared pair, double bond, 3 shared pair, triple bond, right? So we will draw it like this. One shared pair represents 1 dash, other shared pair will another dash, right, like this. These are lone pair of electrons. These electrons have not taken part in bonding, so these are unpaired, these are unshared electrons, or what we call as non-bonding electrons. And these are shared pair of electrons, right, which we call as bond pair of electrons. We have 3 bond pairs, and in the molecule, in each atom we have one lone pair of electrons, right? You need to understand this shared pair and lone pair, because we would be in future we will deal with the geometry of molecules, and these shared pair and lone pair will these we need to be very much clear with the concept of shared pair and lone pair of electrons, right? So now we know that nitrogen is a triple bonded molecule because we have 3 shared pair of electrons, right? So now let's understand one thing, that how come the high force of attraction between molecules. High force of attraction is, how come this bonding will result into force of attraction. Okay, now these shared pair of electrons will lie between these atoms, right? If this is right, these are shared pair of electrons, right? And these shared pair of electrons are at equal distance from both the nitrogen atoms, right? And we know that atoms have nuclei. The nuclei are positively charged, right? So these positively charged, this shared pair is attracting this positive nuclei also, the nuclei of this nitrogen atom also, and nuclei of this nitrogen atom. So there is force of attraction between these electron pairs and the positive nuclei of these atoms, right? Since this shared pair is attracting both the nitrogen atoms, right, because of the positive nucleus, right? So these shared pair will hold these two atoms together, right, in the molecule. So these two atoms are together in the molecule due to attraction by these shared pair of electrons, or this is known as electron rich center, right? This electron rich center will attract the positive nucleus of this nitrogen atom and positive nucleus of this nitrogen atom, right? So since it's attracting both, or this, to be better, this shared pair is attracting this nitrogen atom, the positive nucleus of this nitrogen atom, right, and it's attracting positive nucleus of this nitrogen atom also towards itself, right? Due to this attraction, right, by these shared pair, right, both these nitrogen atoms are together, they have force of attraction between one another, right? So this bond or the force, or the bond is due to this shared pair of electrons, right? This shared pair of electrons will only hold these two atoms together in the molecule, right? That is why we call these as shared pair or bond pair of electrons, right? So I hope this is clear.